Welcome to the channel, everybody. Today we're diving into the fascinating world of artificial intelligence. From its early days to the mind-blowing tech we interact with every day, we're breaking down the evolution of AI decade by decade. Trust me, you don't want to miss this. Picture this, the 1950s. It's a time of big dreams and even bigger computers. We're talking room-sized machines with less power than your smartwatch. But amidst the vacuum tubes and punch cards, a revolutionary idea emerged. Alan Turing, a true visionary, proposed a question that would echo through the halls of computer science. Can machines think? Turing wasn't just pondering, he gave us a benchmark, a test. Literally, the Turing test. Could a machine fool you into believing it was human? It was a simple idea with profound implications, and it set the stage for decades of AI research. Early AI wasn't about fancy algorithms or massive data sets. It was about logic, rules, and trying to teach machines to think like us. Researchers started developing programs like the logic theorist, which could prove mathematical theorems, and the general problem solver, designed to tackle a wider range of problems. These early programs were like the Model T of AI, rudimentary but groundbreaking. They showed us that machines could, in fact, solve problems that were once considered the exclusive domain of human intellect. Think about it. Machines were proving theorems, that was a big deal. Sure, these early systems were limited, but they proved a point. AI wasn't just science fiction anymore. It was becoming a reality. The excitement was palpable. The 1980s, the era of big hair, shoulder pads, and a paradigm shift in AI. Instead of explicitly programming machines with rules, researchers started exploring a new approach: machine learning. The idea was simple but powerful. Let the machines learn from data. Neural networks, inspired by the structure of the human brain, started gaining traction. These networks were made up of interconnected nodes that could process information and learn from examples. It was like teaching a child by showing them flashcards, except these children were algorithms. And the flashcards were data points, but there was a problem, a bottleneck. Training these early neural networks required a lot of computing power, something that was scarce and expensive at the time. Then came a breakthrough, the backpropagation algorithm. This algorithm made it possible to train more complex neural networks, breathing new life into the field. Imagine trying to hit a target blindfolded. You shoot an arrow and someone tells you whether you were too high, too low, to the left, or to the right. You adjust your aim and shoot again, getting closer each time. That's kind of how backpropagation works. Chapter 3. The Data Explosion and the Rise of the Machines, 2000s. The 2000s. The internet happened. Information was everywhere. We're talking about an explosion of data, the lifeblood of machine learning. Websites, social media, sensors, you name it. Data was being generated at an unprecedented rate, and AI was ready to feast. This abundance of data wasn't just about quantity, it was about variety. Text, images, videos, audio, it was all up for grabs. Algorithms, now with access to this massive buffet of information, could be trained on a scale never seen before. One of the areas where this data-driven revolution was most evident was natural language processing, or NLP. Google, a little company you might have heard of, was at the forefront of this NLP revolution. Their PageRank algorithm, which used AI to rank websites, changed the way we search for information online. And let's not forget about the early machine translation systems. Chapter 4. The Deep Learning Revolution, AI on Steroids, 2010s. The 2010s, the decade where deep learning went from a niche research area to a technological revolution. Remember those neural networks we talked about earlier? Well, they got a serious upgrade. We're talking about deeper, more complex networks with layers upon layers of interconnected nodes, capable of learning incredibly intricate patterns from data. And it wasn't just the algorithms that were evolving, hardware was catching up too. GPUs, originally designed for gaming, turned out to be perfect for crunching the massive amounts of data needed for deep learning. This perfect storm of algorithmic advancements and hardware acceleration led to some mind-blowing breakthroughs. Image recognition algorithms became so accurate that they could outperform humans in certain tasks. Speech recognition systems became so good that we started talking to our phones. Chapter 5, The Age of Transformers, Where We Are and Where We're Headed, 2020s and beyond. And that brings us to today, the 2020s. The era of Transformers. These aren't the robots in disguise from the movies. We're talking about a new breed of AI models that are changing the NLP game. Models like GPT-3 and BERT are trained on colossal datasets, able to generate human-quality text, translate languages with remarkable fluency, and answer your questions in a way that can be indistinguishable from a human. But with great power comes great responsibility, right? The ethical implications of AI are becoming increasingly important. We're talking about bias in algorithms, the potential for job displacement, the need for transparency and accountability. These are complex issues with no easy answers, and they're going to require careful consideration as we move forward. That was a journey through the evolution of AI, from its humble beginnings to the mind-blowing technologies of today. We've seen how AI has gone from solving logic puzzles to generating human-quality text, recognizing images, and even driving cars. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more tech insights. Let us know in the comments what you think the future holds for AI.